Hello, this is part 4 of a series on using Tellurium. This is going to be a short one, short video. So let's build a bigger model. So this is what we had in a previous video. We had a single reaction, A goes to B, and a couple of initializations here. And then we had a simulate. Okay, there's a missing bracket there. And then we had a plot. So if I just run this, you'll see what we get. That's basically what we get. Now, one thing, I want to extend this model. I'm going to add another reaction here. B goes to C, and I'll add a single rate constant, an extra one there, and I'll initialize that rate constant. K3 is a 0.1. I'm just making it up. So let's run this one to see what it looks like. So, okay, you can see that there are things still happening. So I'm going to extend this simulation out to 30 time units. So that means just changing this to the second argument to 30. So if I run that, that's looking a bit better. Let's extend it a bit more. Obviously, the rate constants are not high enough. Okay, I think that'll do for now. So you can see in this simulation that A starts to decline. B comes up and then starts to decline a bit, and then C comes up as well. Now, these are just the concentrations. The other thing we could look at are the reaction rates or the fluxes through this pathway. And the question is, how can we do that? So the way to do that is you can name your reactions. And to name a reaction, you just put in a label. I tend to use J1, J2, J3, but you can call them whatever you want, followed by a colon and then the reaction. So this is now a named reaction. And so let me just run this now again. Let me go to this interactive prompt. I can ask for, so remember that load A returns the Roadrunner object, and I've just named it R. If I ask for, let's say, RJ1, it gives me a number. This number is actually the reaction rate through J1. I can also ask for the reaction rate through J2, and that you can see it's slightly different, 0.057. I can also ask for like the concentration of A, concentration of B, and so on. And this is one of the nice things about an interactive prompt. You can actually, have a conversation with your model, so to speak. What happens though if I wanted to actually plot the reaction rate through the first reaction? Well, that's pretty straightforward. And we did this last time. We had this idea of a selection list. So there's a fourth argument you can add to simulate, and that is the list of things you want to get back from the simulation. So these things will end up in M. So in this case, I want to see what's happening to the flux through J1, and let's say I want to also know what's happening to the flux through J2. So this is going to return, I'm going to comment this out just now, the plotting. I'm just going to run this, okay? If I ask it to print out M, I get 3 columns. If I look at the tops of the columns, I get time and J1 and J2. And these are the reaction rates or fluxes through J1 and J2. Okay, so let's now uncover this plot and we'll run it again. Now what you see here are actually the reaction rates through J1 and J2. Okay. Now I'm not limited to just typing in, J1 and J2. I can actually say, well, I also want to know what's happening to the concentration of A as well. So I can run that, and now you get, the concentration of A. Obviously, there's the scale issue here. The fluxes, the rates of fluxes are much less than the concentrations, but still, you can mix and match whatever you want in the selection list. Okay, so I'm plotting here A, the rate through J1, the rate through J2. Okay, I think that's it for that part 4. Okay.